Good morning to everyone. This is Dr. Polaiah. I'm very glad to inform you that we are going to discuss one more topic from our syllabus, that is image processing syllabus. The name of the topic is here morphological image processing. So we are going to have this morphological image processing, which we are discussing based on the previous classes also. So we have, what does it mean morphological? What does it mean such a word, morphological word? Then we can understand how this morphological help us to define image processing. So the word morphology generally represents a branch of biology that deals with the form and the structure of animals and plants. However, we use the same term in mathematical morphology to extract the image component useful in representing the region shape, boundaries, etc. So, in this, what we want to concentrate is a image which we are going to be concentrate on, not only in the region-based image, but also the boundaries which we have to concentrate, which we can represent in terms of branch of biological representation. Let me define what will be the morphology in terms of comprehensive. So, morphology is a comprehensive set of image processing operations that process images based on shapes. Morphological operations apply a structuring element to an input image, creating an output image of the same size. In a morphological operation, the value of each pixel in the output of the image is based on the comparison of the corresponding pixel in the input image with its neighbors pixels. So here you are going to see in detail about morphological operations as we are studying the in terms of morphology comprehensive set of image processing operations. So we going to have such a morphological image processing. Let me discuss with the help of simple image which we are considered here. Image after segmentation, image which we are going to use here in terms of image after segmentation and morphological processing. So segmentation means which you can understand not concentration on the boundaries, but segmentation is concentrating on the image which we are considering is in terms of subparts. It's a subgroups. We are going to be considered subgroups. So group wise, that means subgroup. Subgroup wise we are going to be considered. Subgroup wise we are going to be considered. What we are going to consider in terms of pixels. In terms of pixels, we are going to be considered in terms of pixels. So how can you define that? In the sense, there is a slight overlap between morphology and image segmentation, which morphology consists of methods that can be used to pre-process the input data of image segmentation or to post-process the output of the image segmentation stage. In other words, once the segmentation is complete, morphological operations can be used to remove the imperfections in the segmentation image. So, and deliver the information on the shape and the structure of the image as shown in the following figures. Figure number 1 and figure number 2. So, in this, we are going to have that what we call as segmentation is incomplete. Then we are going to be use the morphological operation. So what I said here, the word morphological image processing is we can connect with the previous class. What we discussed in the previous class, we discussed about image segmentation process. So the segmentation where it has its own demerits or drawbacks. So it will be removed by using the morphological image processing. So we want to concentrate most on the very important point is here the drawbacks of segmentation method. We can we can take help to remove the drawbacks by using the morphological image processing. Let me go to how it is concentrated this morphological image processing for the removing of drawbacks of segmentation. In the sense, we are applying very simply image processing in terms of morphological operations. What will be that morphological operations? How we can consider? Let me see first of all the terminologies which we are concentrating in morphological image processing, which are number one, structure element, where it is a matrix or a small sized template that is used to traverse an image. The structuring element is positioned at all possible locations in the image and it is compared with the connected pixels. It can be of any shape. That means fit is one of the terminology which we are going to use under the structure element, and miss also. So what does it mean fit? When all the pixels in the structuring element cover the pixel object is called we call it fit. Whereas hit means when at least one of the pixel in the structure element covered, this is here, covered the pixels of the object is called hit. So what will be the difference in between this? It is at least, here all. So all, when we consider that, we can come under the terminology of the structuring element of the fit, where at least one of the pixel is covered in the structure element is called hit. So where we are going to consider based on fit and hit, we also define the miss. When no pixel in the structure element, no pixel. So no pixel is in the structure element, then we are going to be used the that we call as a miss. So the difference between fit, hit and miss is here. We are simply compared for the sake of understanding terminologies in morphology image processing. Let me take one example. To understand about the terminology of the morphological image processing. What is that? Let me take on structuring element. So from the structure element only, we are understanding the definitions of or terminology of fit, hit and miss. So see here, so you are taking this as one of the content of the pixel values. Okay, that we are comparing in terms of all. All means comparing each and every part of the pixels. All. So that we come the fit. At least some part we consider is hit. Where this part, this alone is missing, not compared any pixels, no pixels are called miss. So by the word itself we can understand how we define the miss from the structure element. So this figure is represent to understand about comparison in between hit, fit and miss. So that is very important here. Next, so we are going to see this morphological image processing, how it is in aspect of you are concentrating based on the any what we call any noise also we are going to be concentrate for the finding of for distinction of certain brightness or color information in the image which contains certain noise. So for that how we may continue by using the morphological operations are two. Number one is fundamental morphological image processing. Is similar to spatial filtering The structure element is here moved across every pixel in the original image to give a pixel in a new processed image. The value of this new pixel depends on the morphological operation performed. In terms of two most widely used operations are number one, erosion operation, number two, dilution operation. Let me going to see one by another, which are we called mostly widely used morphological operations named erosion, dilution. So let me see the first one. What is this? This is the operation. This is the operation which we are going to understand in easy manner. Erosion shrinks the image pixels, or erosion removes the pixels on object boundaries. First, we traverse the structural element over the image object to perform an erosion operation as shown in the figure. The output of the pixels values are calculated using the following equation of the erosion equation. What is the erosion equation of the is here? Let me define in terms of function. Pixel is a function of output of an image which says as a positive value 1, then it is under the fit. If it is not under the 1, then we called as otherwise become 0 is it says as not fit. So that means erosion is one of the morphological image processing operation where it is concentrated towards to define the value of fit, hit and miss. So here we are concentrating is fit. Fit value is initially if we take this complete pixel values whatever in terms of rows and columns. So where this input image we are considered to get output of a morphological operation of the output which we are by applying the operation erosion, then we are concentrating what part of is here your values of the pixels are become 1, otherwise 0, then the structure element we only this part alone we shaped as a structure element, then this value we got through the morphological operation which we used here erosion. So let me to read once again. That means once again I want to define the structure element which we got is here based on the operation of erosion with the help of calculating of the with the help of output of pixel values which we are calculated by the help of pixel of the output equal to 1. So let me take the example of the morphological operation under the erosion. So what will be this operation is here. What will be the operation is here. Here we are applying example of erosion is shown in the figure. A represents original image. This is original image. Okay. Original image. And B represent and C represents processed images. Both of the we called as a processed images. After erosion, using 3 by 3 pixels of the values and 5 by 5 structuring elements respectively. 3 by 3 is your A, and the A, B and C we are considered as a 5 by 5 pixel element respectively. What we understand from here? We understand here to determine the element of the fit, the structural element of the values which we are considered under the pixels. How many pixels are here from the original image to structural element after applying the erosion is 5 by 2 we got as a 5 by 3 by 3 as the input image. After erosion we got as a 5 by 5 structural element which we are understanding. This, for example, this is 3 by 3. This is what we called as a 5 by 5. What we called as a 5 by 5 structural element pixels. What do you mean to understand this 5 by 5? So a picture image which you are taking, example A, letter A, linguistic value, linguistic variable A is a picture element A. So that is the 3 by 3. From this we are got as a 5 by 5 image. So like that we are understanding here how the morphological image processing applying erosion operation. We understand here in a best process erosion operation with a simple example. So next we will go to the have another, that is second most widely used morphological image processing operation is dilation. Dilation. So what does it mean, dilation? Dilation means expands the image pixels or it adds the pixels on objective boundaries. First, we traverse the structuring element over the image object to perform an dilation operation as shown in figure. That is what we consider. The output pixel values are calculated using the following equation as same as what we concentrated in the erosion way, erosion method, erosion operation way. What is that? Simply we say pixel output is equal to 1. It is hit. Previously under the erosion, hit. What do you mean fit? Fit consider all of the pixels in the consideration of the image taken in input image. Whereas we consider here the pixel output in terms of hit means at least 1 pixel in the image. Okay. So otherwise it become 0. So let you take that. This is your initial. This is your initial object. Okay. And from the original image or from the original image, and we got the output by the help of hit. At least wherever 1 pixel is represent, there we are consider 1 by 1. So there we consider 1 by 1 all the structure element. So this part alone we are drawing to the your structure element. Then we got the output of the initial value. Similarly, what we want to understand under the dilation operation, we also concentrate here is morphological image processing. We concentrate by taking the same example. This is original image. Okay, this is original image. This is original. From this, we concentrated as 3 by 3 to 5 by 5. So what we got from here? So B and C we got the structuring elements respectively. 3 by 3 is your taken as the input image. So what we can understand here, original image as we consider A part, which represent A part, that is A part. This is figure A part, and B and C are considering towards to process the images after dilation using 3 by 3 and 5 by 2, 5 by 5 structuring elements respectively. Okay. So we understand that by the help of this morphological image operations, as we says, there are 2 operations. Number 1, what we call as number 1 is erosion operation. From this we consider the operation which we consider is here towards to calculated the your number of pixels comparing with your initial image to your required image that we call as output. So without we are missing what we call as the terminologies of the morphological image processing, we are using here. There are 3 terminologies. Number 1, fit, hit and miss under the structural. So we got that. And similarly, we represent the same example which help us to understand about the perfectly where we are going to be concentrate to get your original image here. That is under the erosion, one of the example. Coming to the dilation. Dilation also we got, but we have to concentrate here the difference between morphological image processing operations, which are how the difference is here. Erosion is concentrating by the terminology which we concentrate on heat in terms of heat. But whereas dilation is concentrating in terms of I'm sorry. So where we are concentrating erosion is considered is fit, but whereas we are considering dilation is concentrating is heat. So that we are considering. Fit means considering all pixels from the your consideration of the original image, which we are going to transform into according to the structural element of the image processor. And where in case of dilation, we consider as heat. Heat means at least one pixel from your input image to transfer to the your structural element based process. That we consider here. Simply we say and we enrich the your required image processing towards to you got. So by the difference between what we called erosion, dilation, both will help us towards to concentrate to improve the your required morphological image processing. So based on this, each and based on the concentration of each and every pixel process, we are automatically overcome the drawbacks of segmentation process. That is what we had to consider from our discussion of the lecture. So with this, I want to refer some of the list of references where we can also improve further knowledge based on the two references. So I hope you got the complete idea about morphological image processing. And next class we are going to discuss the examples and applications of morphological image processing. With this, I want to say thank you very much for your patient listen, and we can also continue the same concepts with certain examples. Thank you so much. Thank you. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.